So in this section, we're going to talk about optimization problems. Now, there's all sorts of different types of problems, but basically, you end up having something where you get two equations. One that has the information that's fixed, and one that has the information that needs to be optimized. So you might want to optimize the area. Might want to have the maximum area of a certain area of a certain space, such as like a yard. Or you might want to minimize like your surface area of a can, or you might want to maximize your profit. And that's generally your primary equation. So in example one, we want to enclose a field with a fence. We have 500 feet of fencing material, and the building is on one side of the field, so we won't need any fencing, at least for that side. We're going to determine the dimensions of the field that will enclose the largest area. So what I would do first is I would draw out the picture. We have a field, probably a rectangular field. But on one side, we're going to have a building. So we're not going to fence on that side. Okay, no fence. And so we have something like X here, and we got Y, and we have 500 feet of fencing. Now, the primary equation is what you're trying to do. And don't get too confused about primary and secondary. That's not really a big thing. But you need two equations, and we need to figure out which one is the most important. The most important thing is the question. We want the largest area. So area for rectangle is just xy, at least for this rectangle, length times width. And what we want to do is find the largest area, which means we want to, well, find the maximum of this, which sounds like the first derivative test. You find your derivative. You set your derivative equal to 0, undefined, all that fun stuff. The problem is I don't want to do this derivative in two terms. I mean, I can do maybe, I don't know, product rule, and you could do implicit differentiation, but I don't know how fast y is changing. Y doesn't seem to be changing. Like, okay, so we don't want to do that. We want everything in terms of one variable, and then we can take our derivative. That's where the secondary equation comes in. So we got 500 feet of fencing. Well, x plus 2y better equal 500, right? Okay. Now, x and y are completely arbitrary. You can make this x and this y, no big deal. So when you're talking about these equations, we basically have to do substitution. You want to solve for whatever variable you made the easiest. So x equals 500 minus 2y. Okay, perfect. So use that one. Don't solve for y where you have to divide by 2. That would be kind of silly. So over here we've got x, which is 500 minus 2y from the other equation, times y. And that's our area. Now all of a sudden I've got a in terms of two variable. Now you want to think of a more like a function like f of x or a of xy. So currently it's a of just y right now. So when you do the derivative, you don't worry about doing the derivative on the left side. This is just the area prime of y. Now over here you could do something silly, which would be the product rule, or you could just think of this as 500 y minus 2y squared, which is a whole lot easier, because then you can just do your, power rules. 500 minus 4y, and then from here you're going to find where the derivative is equal to 0 or undefined. Okay, well, it's not undefined anywhere, so y is going to equal 500 divided by 4, which of course I want to guess. Alright, then bring up my calculator. Yeah, if you get stuck doing this, you get stuck doing this. Alright. Of course, I didn't really give myself much room here. And then you get 820, 125. Alright, perfect. 125. Alright, so now we got y. Now the truth about this is you really should make sure that it is a maximum. Now most people get this number, and 99% of the time, maybe not 99, maybe more like 90% of the time, that is going to be your relative maximum or your absolute maximum. But sometimes it's not. I mean, you really, really need this to be the number. Okay, so I'm not really looking for a relative maximum, I'm looking for absolute maximum. So absolute maximum happens at critical points, which is here, or endpoints. Okay, well, where are the endpoints? Well, the endpoints here, think about x. If x was 0, such as we had like a really skinny fence, what's my area? Well, 0. Okay, that's not very good. Okay, well, what if y was 0? And we stretch that way out this way. Now we got no area. So it's not the endpoints. Those endpoints are where the area stretched way out in one direction to the other. So it must be this value. And you really should be plugging them into your area equation. Figure out what the area is at y equals 125. But most of the time, this value will be the number you're looking for. Now, the only thing is, I want the dimensions, not just y, but x. Okay, well, over here I said x equals 500 minus 2y. Well, 2 times 125. So 500 minus 250 is 250. So our dimensions are 250, usually x by y, but by 125. You can put them in the picture if you'd like to, and I don't know that there's a particular order that they have to be in, but those are the dimensions of your field. So, just to recap the problem here. Draw a picture if you can. Try to figure out what the picture's telling you. You generally need two equations for this. You need the one that needs to be optimized, the one that's the question. Generally, you want to find the maximum of something. It will usually have more than one variable in it. If it doesn't, you're probably not doing the problem correctly. Then you get your secondary equation, which has something that they give you, has a number. You want the surface area to be this. You want your area to be this. You want your profit to be this. You want your, something where you're equal to something. You're going to substitute one of the variables back into the other equation, and then you're going to find the maximum. And that happens when the derivative is equal to 0 or undefined. Don't forget the undefined part. All right. Let's try one more, just pretty straightforward problem. Okay, so we're trying to figure out that the product of one number and the square of the other number, so x times y squared, is maximum. This is the thing we're trying to maximize. We're trying to maximize whatever this is equal to. So we want to take the derivative of this and set it equal to 0, or undefined. But this is our primary equation, the one we're trying to take the derivative. The secondary equation is this part right here. We want two non-negative numbers whose sum is 9. So x plus y equals 9. Okay, that's pretty straightforward. So x equals 9 minus y. All right, plug that in. So 9 minus y times y squared. 9y squared minus y cubed. That's our thing we want to maximize. So if you want to ever maximize anything, you take the derivative and set it equal to 0. Okay, well, the thing about this one is there are two answers. So if we take out, let's see here, we got take out 3, y, leaving us with a 6 minus y. Okay, so we have y equals 0 and 6. Okay, well, a couple things we can kind of throw out here. So if y equals 0, well, you can have 9 and 0, I guess. So we have, if y is 0, then x equals 9. So we got 9 and 0. And then we've also got, if y equals 6, we got 6 and 3. Okay. So how do I know which one it is? We got two of them. And we also have, well, the boundaries, but how do we come up with boundaries in this one? X plus y equals 9. Well, that's kind of hard because they have to be non-negative numbers. Well, you have, I guess the boundaries would be 0 because you can't go left of 0, right, on the number line if we want to be non-negative. And if you want to talk about infinity, infinity plus some other non-negative number is not going to get 9. So these are the two we're looking at. So, well, which one is it? Well, you plug into the original to find out which one is the maximum. That's what you always do with absolute maximums. And this is what you're trying to do. You want to find the maximum, the absolute maximum of the two, not a relative. So, plug them in and see what happens. So, and you got to be careful about the fact that we have x and y. So these were y numbers. And so actually, I didn't really notice that the order matters. The order does matter big time. So if the y is the 6, the x is the 3 for this particular one. So 9 minus 6 is the 3. Because when we plug it over here, y is squared, not x. Okay, so if we choose this one, we get 9 times, well, 0 squared. Oh, that's drops out real fast. And I'm going to assume the other one's not going to. And it really doesn't matter. We know this one is the maximum because it's bigger than 0. So we're not always looking for the actual number. And it could be find the actual maximum of the product. And the maximum of this product would be 36 times 3, which is 108, I believe. But that's not usually important. What's usually important is the two numbers.